Now we're going to introduce the idea of polyatomic ions. Before we had monoatomic, meaning they were made of one. Polyatomic ions are ions that are made from two or more atoms. And those atoms are covalently bonded as opposed to ionically bonded. Here is a list of polyatomic ions. This is on the back of your periodic table that I gave you at the beginning of the year. Some of these are very straightforward. Others are a little tricky. For that reason, I'm going to have a candy bar quiz in order to get you to name these guys. All right? Let's see if it'll write. OH is hydroxide. CN is cyanide. NO2, nitrite. NO3, nitrate. You'll notice that the CN doesn't have an oxygen on it. It ends in "ide." But nitrate and nitrite both have oxygens. Oxygens give the ending either an "ate" or an "ite." 8 is going to have the larger number of oxygens. Ite is going to be the smaller. Now this works for a few of these. It works for nitrate and nitrite. It works for sulfate and sulfite. It works for phosphate and phosphite. It does not work for the halogens, though. The halogens, what you're going to have to do is remember, if you get a halogen, there's 4 possible positions. That's our next 4 on here. Let's see if I can change color here. Our halogens, we have chlorate, which is O3. We have chlorite, which is ClO2. We have ClO and ClO4. They all are a -1 charge. Chlorate is ClO3. When we add an additional oxygen, we get ClO4, and that name is perchlorate. So perchlorate, then chlorate, then chlorite, and then for our ClO, which has only 1 oxygen, we put a hypo on the front, that's supposed to be circling, of chlorite. So we have perchlorate, chlorate, chlorite, hypochlorite. And I don't know how to remember them except to tell you, you gotta memorize them. Okay? Notice iodite's right under here. Iodate, is IO3. Can you guess what iodite would be? Iodate, IO3, chlorate, ClO3. So iodite would be ClO2. You don't have to memorize iodite, but you do have to know IO4, which has 1 more than iodate, and that is periodate. This guy is bromate. He's also from that same family. BrO3 is bromate. If we had BrO4, he would be perbromate. BrO2 would be bromite. BrO would be hypobromite. All right, enough with the halogens. Now we have one that makes no sense. Permanganate. Manganese is not in the column with the halogens, and none of the other transition metals have a per in front of it, but manganate does. This is permanganate. Now if we look at the other transition metals, molybdate is MoO4. Why isn't it permolybdate? I don't know. It's another one of those mysteries. Another one from the transition metals is chromate. Again, CrO4. I wish there was a pattern here, but there's not. Chromate has a friend, dichromate, Cr2O7. Those are pretty easy to distinguish between. Okay? Now let's look at carbonate, CO3. Starts with carbon. Silicate, silicon is right beneath carbon in the periodic table, SiO3. Selenate is 1 over, SeO4. It's right under, selenium is right under sulfate, which is also an O4. Now we have a couple that have hydrogens in front of them. They're familiar to us. We have HSO4, HSO3, HCO3. All three of those, we can look up SO4. We know, I don't know why that did that. It's sulfate. When we put the hydrogen on, it becomes bisulfate. You will also see it named hydrogen sulfate. I will accept either name. So SO3, because SO3 is sulfite up here, he's either bisulfite or hydrogen sulfite. CO3 is carbonate, so he's either bicarbonate or hydrogen carbonate. Okay? Tetraborate is on my particular list twice. I think yours only once. There's 4 borons. Tetris is a game that has 4 blocks in each shape. Tetra means 4. Tetraborate, B4O7. Again, if you see the bor, B, you know it's got to be boron something. Now we're getting into things a little bit trickier. I'll pick a color we haven't used. SCN. We know that CN is cyanide. SCN, when we put a sulfur in front, we get the prefix thio. Why is it not thiocyanide? I don't know, but for whatever reason, this breaks the oxygen rule. This is the only non-oxygen that gets an 8 at the end of it. I don't know why. 2 more, or another one that has an extra sulfur, is thiosulfate. To me, this should be thiosulfite. It's weird, I know, but hopefully, because I'm going to do basically a matching quiz, thio will tell you to look for an extra S. The sulfate, hopefully when you see S2, you'll be able to get past the fact that SO3 should be sulfite. Peroxide, oxygen normally is a -2, so if we have 2 oxygens, it should be a -4, right? Nope. In peroxides, it's a -1. So each oxygen is a -1. We have 2 that have iron in them, ferrocyanide and ferrocyanide. Ferra, -3, I becomes before O in the alphabet. -3 comes between -4, at least for most people who are counting. You may be different. You may count in a different way. I don't know. The last 4. Oh, you can't read that. Citrate, tartrate, oxalate, and acetate, which is written in 2 different ways. Not sure why. Acetate these are both ways to represent the compound. The second one is the organic way. We're not going to worry about that. It's not even on your sheet. The first one is the one we're going to learn. Acetate. C2H3O2. I don't have a way to remember that, but I do for the other three. Oxalate. If you think about oxalate, it sounds like oxen. C2O4, if you think about, if you had a covered wagon, you would have 4 wheels. And you have the little thing over it. That's a really bad covered wagon. But you'd have 2 oxen pulling your 4 wheels. 2 oxen pulling 4 wheels. It's a stretch. Go with it. The next one, tartrate. C4. Remember we said that 4 was tetra. Well, we're going to go with tart as well. So if you can remember, tartrate is C4. Tetra is also a 4, B4. It's close enough, maybe it'll work for you. Citrate, 6 starts with the sound. Citrate starts with a sound. That's how I remember that one. Those are all the negative ones. The last one we have on here is ammonium. He is the only positive polyatomic ion that we will deal with this year. So there you go, NH4 with a +1. All right, hopefully that will help you learn how to name these.